Okay. Buongiorno. Can I see how many people here are from Bologna? A show of hands. Oh, not that many. A few. You have a lovely city. I always enjoyed coming back here. Been coming for many years, including coming to the very first from the front. So it's great to be back here. There you go. So this morning, I'd like to start off with a bit of a story, or more accurately, a creation myth. You may have heard that the internet was created so that there could be a network that would withstand nuclear attack. That's not true. What is true is that Paul Baran, who was working at the Rand Corporation, was investigating how to make resilient networks. How do you make a network that stands up to attack? And it was out of this that came the idea of packet switching, where instead of sending the whole thing you want to send, you break it up into small packets, and you route those packets around the network in whatever order is best for the individual packets, and then you put them back together. Now, this idea of packet switching caught the eye of Leonard Kleinrock, and he was working at ARPA, the Advanced Research Projects Agency, where they were trying to build a network. And this packet switching idea got incorporated into what was known as the ARPANET. Now, to begin with, the ARPANET was extremely small, just a few nodes of universities. And the very first message was sent on the ARPANET in 1969. It was October 29th. And the message was simple. It was just a command from one computer in Stanford, in UCLA, to another computer in Stanford to log on. And so the message was sent, and the whole system crashed after 2 characters. So this was the first message ever sent on the ARPANET. Low. But they worked on it, right? They fixed the bugs, and it began to grow. More nodes added to the network throughout the 70s. It grew and grew until it was sort of turning into this network of networks, or internetwork, if you like. And it's at this point it becomes really important that these different networks on this meta network are all speaking the same language, at least at a low level, so that they can communicate. And this is where the ARPANET really starts to morph into the internet. And it's thanks to Bob Kahn and Vint Cerf. Now, at the time, these idealistic young people were not concerned with making a network resilient to nuclear attack, but they were very concerned with making a network that was resilient to any kind of top-down control, that the network would have no center, that you didn't need to ask for permission to add nodes to the network, right? So they created TCPIP, and baked into this was the idea that the network is dumb. It's deliberately dumb, as in all the intelligence resides in the nodes, and all the network does is route those packets around. And the network does not care what the contents of the packets are. All packets are equal. And this turns out to be the secret sauce of the internet, the fact that it's a dumb network by design. So they created TCPIP, the Transmission Control Protocol, and the Internet Protocol. And this is just very low-level way of making sure that everyone is speaking the same language. And when you think about what a protocol is, it's really just an agreement. And they deliberately made this as simple as possible. At the time, they used to joke that you should be able to make TCP/IP work using 2 tin cans and a piece of string. And the idea is that once you've all agreed to use this low-level protocol, anyone is free to build more complicated protocols on top of that. You can create a protocol for sending and receiving email, Telnet, Gopher, file transfer protocol. If you wanted, you could just create a new protocol today. You don't need to ask anyone for permission. Just make sure it's built on top of TCP/IP. See, coming up with a new protocol isn't the hard part. The hard part is getting people to use your protocol, right? Because you want to make sure you're making full advantage of Metcalfe's law. Right? Bob Metcalfe, he worked on the ARPANET. He also worked on Ethernet, and he came up with this law. It's like the value of a network is proportional to the square of the number of nodes on it, something like that. Basically, what he was saying was, the more people are on the network, the more powerful the network is. Seems pretty obvious, and it's true. You think about the first person who ever had a fax machine, they had a completely useless machine. It wasn't until one other person had a fax machine that it became twice as powerful. So this was the situation where anyone is free to make a protocol. This was the situation when a new protocol arrived on the scene, the Hypertext Transfer Protocol. And this protocol was just one piece of a three-part stack. You got the protocol level with HTTP. You've got URLs as identifiers built on top of the domain name system. And you've got this really simple format, HTML. And together, they formed this project called the World Wide Web Project, created by Tim Berners-Lee. I should point out that in this picture, he's just created the World Wide Web Project. At this point, it only exists on one computer, his computer, and he still called it the World Wide Web. That is confidence. And the situation that Tim Berners-Lee was in, he was working in a very interesting environment. Well, probably the most interesting place on the planet. He was at CERN, the European Center for Nuclear Research. Right? So underneath the border of Switzerland and France, there's the most complicated machine ever created by human beings, the Large Hadron Collider, and they spin it up, and they're firing protons close to the speed of light, and they're creating conditions from near the start of the universe. And there's a lot of data being exchanged here, right? Now, what's really interesting at CERN is that there's really very little hierarchy. You've got Nobel Prize-winning physicists collaborating with students on their summer internships on these experiments. And so there isn't really a consensus about what formats to use, what protocols to use, how information gets managed. You can't dictate to the people working at CERN, oh, you've all got to use this operating system or this particular piece of software. So this was the challenge that was facing Tim Berners-Lee. And he decided to use a hypertext system to try and solve this. Now, interestingly, this wasn't Tim Berners-Lee's first attempt at a hypertext system. About 10 years previously, he created a system called Inquire. The full name was Inquire Within Upon Everything, named after this Victorian book of manners, which I always thought would be a great name for the web, right? Inquire Within Upon Everything. And he put the ideas from Inquire, and he took the philosophies from the internet itself, this dumb network where nobody needs to ask for permission, and he put it into a proposal with a very unsexy title, Information Management, a Proposal. Well, his supervisor, Mike Sendall, must have seen something in this proposal because he scrawled across the top, vague but exciting. So Tim Berners-Lee gets to go ahead and creates the web. Good job, Tim Berners-Lee. And Tim Berners-Lee understood that you didn't want to create something brand new from scratch and try and convince everybody to use this brand new system. Now, instead, try and create stuff that's simple so that people can get started easily. Don't try and completely change people's behavior. Just see if you can nudge people's behavior. It's like that apocryphal Einstein quote, right? That everything should be as simple as possible, but no simpler. And I think if you look at those building blocks of the World Wide Web, it's kind of true. None of these things are perfect. Far from it, right? Not the best protocol, maybe not the best way of identifying things, certainly not the best format, but they're simple. They're simple and just powerful enough that people could get started with them pretty quickly. Certainly, if you look at HTML, to begin with, very simple indeed. There was no official HTML version 1 specification. There was just this document called HTML tags, presumably written by Tim Berners-Lee, that listed the entirety of HTML, which was 21 elements. And even those 21 elements, Tim Berners-Lee didn't invent them out of nowhere. He borrowed them wholesale from an existing language being used at CERN. The scientists at CERN were using a version of SGML to write their papers and stuff. So by taking the elements from SGML and saying this is what HTML is, It was really familiar to people, and so they were able to get started pretty quickly. Now, if you look at HTML today, it is no longer 21 elements, it's about 121 elements. And yet, it's still HTML. Now, that kind of blows my mind, that it's still the same format. About 25 years on, that we still have the same format. Yes, it's grown by 100 elements, but it's still HTML. I find this kind of amazing, because if you know anything about file formats, the idea of something lasting 25 years is pretty crazy. If you took a word processing document from 25 years ago and tried to run it today, you're going to have a bad time. And yet you could take a modern web browser and you can still read the very first web page ever written. Or you could take a web browser from 25 years ago and still parse today's HTML. Now, the reason why HTML has been able to grow so much and yet still remain HTML, I think, is down to a design decision within HTML. It's about how browsers parse HTML. So think about what happens when a browser is confronted with an element. You've got an opening tag, you've got a closing tag, some content in between. Maybe you've got some attributes on that opening tag. Well, the content in between the opening and closing tag is shown to the user. Depending on the elements, maybe something extra happens. Maybe you get some default browser styling. Maybe you get some extra semantics. Maybe you get some extra functionality, if it's an A element or a form element. But fundamentally, this is what happens with most elements. You got the opening tag, closing tag, the content in between. You see the content in between. You all know this. But think about what happens when you give a web browser an element it doesn't recognize, an element that doesn't exist. You still got that opening tag, you got that closing tag, you got that content in between. Well, it just shows the content in between. What's interesting here is what the browser does not do. The browser does not throw an error just because it doesn't recognize the element. The browser does not stop parsing the HTML file at this point and refuse to parse any further. It just skips the tags it doesn't understand and displays the content in between those tags. Well, that's the secret sauce. That's how HTML managed to grow by 100 elements, because that means we can add new elements to HTML over time and know exactly how older browsers will behave. They'll ignore the tag part and just display the content. That's so powerful. In fact, we can use this to our advantage. Think of a complex element like canvas, which you kind of require scripting to make use of. Well, if we know that older browsers will display whatever is between the opening and closing tags of an element they don't understand, then let's make the newer browsers not display what's in between the tags, and so we can put fallback content in between the opening and closing tags, specifically for older browsers. This is not an accident. This was designed this way. The canvas element actually started life as a proprietary invention by Apple. This is kind of how a lot of standards get started. One browser just makes something up. The other browsers say, ooh, that's nice, we'll have that. And then it gets standardized. But when it was a proprietary element, Canvas didn't have a closing tag. It was one of those self-closing elements like image or meta. But when it got standardized, they made sure it got a closing tag specifically so we could do this, so that we could give fallback content. It's interesting to see that it's kind of an archaeology of HTML when you go back to older elements, like the image element. The history of the image element is kind of fascinating. In the early days of the web, there was this mailing list called www.talk. And pretty much everyone who was on the web was on the mailing list, and pretty much everyone who was on the web was making a web browser. It was pretty much a mailing list for people making web browsers. And they were talking about adding to HTML. Now, this time there were no images in HTML, so this is under discussion. What should we call this element? Some people are saying we should call it object, because maybe one day there won't be just images on the web, but there might be video as well. Some people were saying it should be called icon, and the discussion is going on. And then Mark Andreessen, who was working on the Mosaic browser, he says, guys, I've just shipped it, and I called it IMG. It takes an SRC attribute, and it's going to be in the next version of Mosaic. And everyone else on the mailing list went, okay. Because it's kind of that mantra of the Internet Engineering Task Force, which is, rough consensus and running code. They had the rough consensus, but as soon as it shipped in a browser, they had the running code. So this is what we're stuck with. Now, it's actually not ideal. Because it's a self-closing element, we don't have a closing tag, so we don't get to put the fallback content in between the opening and closing tags. Instead, we have this alt attribute. It's kind of hidden away. It's a bit more work for us to remember to put in the value there. But image worked, for a while. But there was always this kind of fundamental philosophical mismatch between the fluid nature of the web, or the fluid nature of text on the web, and bitmap images that have a fixed width and a fixed height. And we kind of ignored this problem for a long time. We pretended that all websites are 800 by 600 pixels or 1024 or whatever. But then along comes responsive design, and we have to change our ways. Thanks, Ethan. And so we have to figure out a way of giving the browser alternate images it might want to use in different circumstances. And so the community group, responsive images community group, come up with SourceSet. Now, here's what I love about the design of this. We're adding a new attribute to HTML, and the way that older browsers treat attributes it doesn't understand is pretty much the same way it treats tags it doesn't understand. It ignores it and carries on, does not throw an error. So we know it's safe for older browsers to start using SourceSet. They'll just ignore it. But the real genius here is that SourceSet doesn't replace the source element. It updates the value of the source element. And if you try doing responsive images where you use SourceSet, but you don't use a good old-fashioned source attribute, it won't work. You have to have the source in there. See, that's why I like it. The backwards compatibility is built in. You must provide the fallback. It's the same with all the responsive image stuff. If you use picture, if you use the source element, what all this stuff does is update that source attribute. So backwards compatibility is built in. And it's possible for us to extend HTML this way, to add new attributes, to add new behaviors, new elements, because of the error handling, because HTML does not throw an error, because it doesn't stop parsing the document every time it comes across something it doesn't understand. So that's a hugely powerful pattern. And it's the same pattern in CSS, the same way of handling errors. Now, if you think about all the websites out there using CSS, which is all of them, and you think about how different they look, how varied the look and feel, the styles, the designs, and then think that all of that comes down to one pattern. You have a selector, a property, and a value. That's it. That's all the CSS that's ever been written and ever will be written. Of course, the hard part is remembering the vocabulary of the selectors and the vocabulary of the properties and the vocabulary of the values. But fundamentally, all CSS boils down to this: selector, property, value. Yes, we have a couple of extra characters so that the machines can parse it, curly braces, colons, semicolons. But it's such a simple and, I think, beautiful pattern. And if you think about how a browser parses CSS that it doesn't understand, let's say you give it a selector it doesn't understand, well, it just skips over the curly braces for that selector. Again, it does not throw an error. It doesn't stop parsing the CSS file at this point and refuse to parse any further. It just skips over what it doesn't understand. If you give it a property it doesn't recognize, it just skips that particular declaration. Give it a value it doesn't recognize, it just skips that declaration. Doesn't throw an error, doesn't stop parsing. So that's hugely powerful. Now, thinking about CSS in the last, let's say, 5-6 years, I'd say there's been two major developments. One is the use of things like preprocessors and postprocessors, stuff like less and sass. Who here is using sass or something like that when they're writing CSS, right? Most of them. And the other big development is the introduction of, I guess, systems of naming things, right? You've got object-oriented CSS, you've got SMACs, you've got BAM. Who's using some kind of naming system like this, BAM or something? Right, quite a few of us. Now, what I find fascinating about both those developments, preprocessors, naming conventions, is that in neither case did we, developers, authors, have to go to the standards bodies, go to the browsers and say, please implement this. We really need this feature. In the case of preprocessors or postprocessors, it's because it's on our computers. It's not in the browser. And in the case of these naming conventions, It's because everything we needed is already in this pattern. If you think about what BAM is, or SMAX, or any of these things, it's kind of a rule system for your selectors, and pretty much just a class selector, which has been in CSS from day one. So I find this kind of amazing that theoretically, we could have been writing BAM 15 years ago. It's like the power was there all the time, staring us in the face, and we didn't see it. And I'm going to come back to that idea that stuff can be staring us in the face and we just don't see the power of it. So CSS and HTML can grow over time because of the way they handle errors, the way that they treat things they don't understand. Turns out to be extremely resilient. And I see this as an example of the Robustness Principle, also called Postel's Law, that you should be conservative in what you send, be liberal in what you accept. Now, John Postel, he was working on the ARPANET, he was behind the DNS system, and he was talking about packet switching when he came up with this principle. So if you receive a packet and it's not totally well formed, but you know what you're supposed to do with it, say, well, just do it anyway, right? Don't complain that it's not well formed. But if you're sending a packet, you're creating one, try to make it as well formed as possible, right? Be conservative in what you send, be liberal in what you accept. Now, this might sound like this belongs to the realm of engineering, but I see Postel's law at work all the time. I see it at work in the worlds of design and UX. Let's say you're putting a form online on the web. Well, number one rule is, use as few form fields as possible. Be conservative in what you send to the user. But then when the user is filling in that form, don't make them format their telephone number a certain way or their credit card number a certain way. Be liberal in what you accept. So Postel's law is kind of everywhere, and I think it's very much there in the way that browsers parse CSS and HTML. The browsers have to be liberal in what they accept. Now, I think that CSS and HTML can afford to be liberal in their error handling because of the kind of languages they are. They are declarative languages. That means you don't tell the computer exactly what it should do. It's more you say what you got, these are my elements, you say the style you desire, and you leave it to the runtime environment, the web browser, to figure out the details and do the legwork. So a declarative language is not precise. It's not that powerful, but it can afford to have this lax error handling. And also, in my opinion, declarative languages tend to be much easier to learn, probably because they aren't as powerful as, say, an imperative language like JavaScript in the web browser. Now, JavaScript can't really have the same error handling model as CSS and HTML, because here you are telling the computer exactly what to do, which is extremely powerful. But if you make a mistake in your imperative language and the browser was just like, don't worry about it, it's fine, that would not be helpful. So with JavaScript, if you give the browser some JavaScript it does not understand, it will throw an error. You give the browser some JavaScript it doesn't understand, it will stop parsing the JavaScript file at that point and refuse to parse any further. It kind of has to, because it's a powerful imperative language. So this is a broad sweeping generalization, but I would say in general, declarative languages can be more resilient because they can have this error handling, and imperative languages are by their nature more fragile, but more powerful. Now, it's interesting, if you look at the history of how we solve problems on the web, what tends to happen is we figure it out first in the imperative layer. We hack something together in JavaScript, and if it's a good pattern, over time it finds its way down into the declarative layer. So if you think about the very first uses of JavaScript, I'm showing my age here, but I remember we would use JavaScript to do image rollovers. So you mouse over something and it changes the image. And form validation. Oh, you have to fill in that form field. Oh, that doesn't look like an email address. Now these days, I wouldn't use JavaScript for either of those things. If I wanted to do the rollovers, I'm going to use CSS. And if I want to use form validation in the client, I'll use HTML, required attribute, type equals email. Right? So these things found their way down into the declarative stack. And the responsive images solution is another example. We polyfill this stuff, we make something that works in JavaScript, but over time we want to make sure it gets stable and it lands in that more resilient layer of the stack. So this is kind of the nature of the front-end stack. Fragility, but power, with the imperative part for JavaScript. Resilience, but maybe not as much control, with the declarative layer, HTML and CSS. What's interesting is that we once almost had the worst of both worlds. It was about 10 years ago. Yeah, trigger warning, XHTML2. So this was when the W3C had decided HTML was done, XML was the future, we're going to reformulate HTML as XML. Now to begin with XHTML1, this is absolutely fine, because all we were really borrowing from the world of XML was the syntax. And the syntax of XML is very like HTML, except all your tag names must be lowercase, all your attribute names must be lowercase, you must quote all your attributes, whereas in HTML it doesn't matter, uppercase, lowercase, quoted, unquoted, doesn't make any difference. So XHTML1 was kind of nice. It gave us this, this standard way of showing you're a professional developer by writing your HTML in a nice, strict way. XHTML2, however, was going to be a completely different kettle of fish. As well as having completely new vocabulary and deprecating things like the image element, it was going to borrow the error handling model of XML and apply it to HTML. And here's the error handling model of XML. If there is a single error in the XML document, do not parse the document. So if there's one unencoded ampersand in your page, it's the yellow screen of death. The user sees nothing. Now we, collectively, designers, developers, authors, we took one look at this and we said, no way. There's no way I would put that on the public web, something so fragile that if there's one error, the content doesn't even display. We quite rightly rejected it. And here we are 10 years later. And we're building websites where just to see content on a screen requires the most fragile part of the stack. Somehow, in 10 years, we've come around to the idea that making the most fragile layer, the bit we rely on, is totally okay. I remember a couple of years back, there was a day when nobody could download Google Chrome. Nobody could download Google Chrome because on the page for downloading Google Chrome, there was a JavaScript error in a JavaScript file, probably completely unrelated. Now, this shouldn't affect the ability to download Google Chrome. We can see there's a link to download Chrome. But the problem was, if you look at that link, instead of having a proper href, it was the JavaScript pseudo protocol. So it was like taking the most fragile layer of the stack and pushing it down into the declarative layer. Now you've got all the fragility of JavaScript in your declarative layer. And sure enough, one error in the JavaScript, because of the error handling model of JavaScript, nobody can download Google Chrome. I'm pretty sure heads rolled for that. And this brings up a law that I think on the web is just as important as Postel's law, and that's Murphy's law. Anything that can possibly go wrong will go wrong. Murphy was a real person. He was an aeronautical engineer, and because he had this attitude, nobody ever died on his watch. I think it's a pretty good attitude to have. And I think we sometimes put our fingers in our ears and say, no, everything's going to be fine. Let's assume that the JavaScript will be fine. Stuart Langridge put together a whole flowchart of all the things that can possibly go wrong with JavaScript on the client side. And some of this stuff is in the browser, and some of this stuff is on the network itself, and some of this stuff is on the server, right? Things that can go wrong. Now, of course, things can go wrong with your HTML and your CSS too, but because of the error handling model of HTML and CSS, it's probably going to be okay, right? The browser's going to recover. Whereas with JavaScript, depending on how you're using the JavaScript, it could literally make or break your website. Now, other industries take this seriously. You think about the car industry, and they strap crash test dummies into cars, and they smash them against walls at high speed. And could you imagine if the car industry said, actually, we've been thinking about this. We're not going to strap crash test dummies into cars and drive them against walls at high speed, because we're imagining that actually these cars won't be driven by crash test dummies. They'll be driven by human beings. Also, we anticipate that these human beings will drive these cars on roads and not smash them into walls at high speed. Like, well, yes, of course, this is what we hope for, and you can hope for the best, but you still need to prepare for the worst. My friend Trent Walton talked about this exact thing on the web when he said, like cars designed to perform in extreme heat or on icy roads, websites should be built to face the reality of the web's inherent variability. The reality of the web's inherent variability. Right? We need to face up to that reality. Okay, this all sounds very gloomy and indeed doomy. It sounds like I'm saying we're screwed, don't use JavaScript, right? That is not what I'm saying. I did not come here to give you problems. I've come to give you a solution. This solution takes the form of 3 steps. This is how I like to approach building for the web, and I encourage you to build for the web in this way too. 1, identify the core functionality of what it is you're building. What's the one thing all your users need to be able to do? Don't identify all the functionality, just that core functionality. Once you've identified that core functionality, make that core functionality available using the simplest possible technology. Again, not the best possible technology, the simplest. The reason why you want to use the simplest technology is that the simplest technology is probably the most resilient and widely available. But you don't stop there, because it's at step 3 that you get to have fun. Step 3, you enhance. Now you're free to add all the cool stuff, safe in the knowledge that you've built a baseline on which you can enhance this stuff. Let's take a look at some examples of this in action. Suppose you're a news provider. We're going to identify the core functionality of a news provider. Well, that's kind of it right there, right? To provide the news. Now, I'm not even talking about technology here, just what the users want from us. They want us to provide the news. Okay, let's say you've got a social network where people all over the world can send each other messages and receive messages. Well, there's the core functionality right there. The ability to send messages and the ability to receive messages. Let's say you've got a photo sharing service. The clue is in the name. The core functionality is the ability to share photos and to see photos from other people, I guess. Again, we're not even talking about technology here. And let's say you've got an online tool for collaboration so that people can write and edit and share documents. Well, there, we've just enumerated the core functionality: writing, editing, sharing. Okay, once you've done that, once you've identified that core functionality, now make that functionality available with the simplest possible technology. This probably means, boring old technology. So in the case of the news site, how can I, in the most simplest way, provide the news? Well, probably mark it up as HTML and send it down as an HTML file. Technically, the simplest way would actually be maybe a text file, but I'm going to allow myself to raise the bar slightly and say, no, we'll use HTML. That's it. In the case of a network, we need to be able to see messages, probably in reverse chronological order, so there's HTML to do that, an ordered list. And we need to be able to send messages, and this is where forms come in. So in this case, pretty simple form, probably input type equals text. Done. Very similar in the case of a photo sharing service. This case, the reverse chronological list is going to be showing image elements. And our form this time is going to be slightly different. Instead of type equals text, it'll be type equals file. That's probably the simplest technology you can use to enable the core functionality. And in the case of a collaborative writing app where people can write and edit and share, another form with a text area. Okay, now you've done that. You've made the core functionality available to the widest number of people. But please don't stop there. I mean, if you stopped your product at that point, I wouldn't hold my breath waiting for the IPO, because what you need to do is make it sing, right? Now you need to really make it stand out from the competition, and that's where we go to step 3, you're enhancing, and this is where you want to be spending your time, because this is where the fun happens. So in the case of a news site, okay, it's an HTML document being sent down the wire. How can I enhance it? Well, I can make it look beautiful by using layout. And it might seem strange to think that layout is an enhancement, but if you think about responsive design, particularly mobile-first responsive design, that's exactly what layout is. We have our structured content, we have our styles for small screen, and then we add on the layout for larger screens as an enhancement. Now, When I say something is an enhancement, please don't misconstrue that I'm saying something is just an enhancement. Enhancements really, really matter. Like I say, that's what makes your service stick out from the competition. Beautiful typography using web fonts, a fantastic enhancement. I wish I could say it's not an enhancement, that it's something core to the web. I love typography. But being honest, it's an enhancement. Not everyone will get your web fonts, and that's okay. Everyone is going to get your core functionality. In the case of that social network, we'll obviously use the same technologies, layout and web fonts. But in this case, we've got that really clunky, sending to the server and receiving a full page refresh back every time I send a message. Let's fix that. Let's add Ajax so that when I send a message, I don't have to refresh the whole page. In fact, let's make it so that when other people send messages, I get that in my browser without refreshing the whole page using WebSockets, some technology like that. Maybe WebSockets aren't supported in every browser. That's totally fine, because the core functionality is supported in every browser. In our photo sharing service, we're going to use everything we've said before, right? Layout, and web fonts, and Ajax, and WebSockets. But let's have some fun when that image lands in the browser. We've got a file API, and we can do fun things with the image before it's even sent to the server, like adding CSS filters. Put a nice sepia tone on that image. And these things aren't necessarily supported in every browser. That's okay. The core functionality is supported. And in the case of our writing app, all the stuff we said before, right? WebSockets and Ajax and all that cool stuff. But let's go further. Let's not rely on the server for even storing this stuff. Let's use some form of local storage. And there are many options now for local storage in the browser. And let's go one further. Let's make it resilient to the network itself being flaky, and let's use something like Service Worker. Oh my God, I love Service Worker. This is the technology I am most excited about right now. The idea that you can make your service work offline, that the network itself could be treated as an enhancement. Hugely powerful, fantastic tool. Please investigate Service Workers. And you know what? Service Workers aren't supported everywhere, and that's okay. Right? Your core functionality is still available to everyone. So that's the three-step process. What I like about this three-step process is that it's kind of scale-free. I've just been talking at the level of the entire service, but you could imagine applying this three-step process at the level of a URL. What's the core functionality of this URL? How do I make that core functionality available with the simplest technology? And then how do I enhance this URL? Or go further. We're all thinking in a modular way these days, right? Components. You could apply this three-step process to a component. What's its core functionality? Maybe providing address details. Okay, simplest possible technology, text on a screen listing the address. How do I enhance? A map. I can enhance further, a Slippy map. I'll add some CSS transitions, right? So this way of thinking can be applied at different levels. And fundamentally, what I want to break away from is this idea that you have to choose, that you can either have a robust, resilient, but boring website that's available to everyone, or you have a rich, immersive website, but it only works on the latest and greatest browsers. I'm saying you have both. And I don't mean it's separate URLs or separate subdomains. I mean the same code base is simultaneously the boring, old-fashioned service and the latest and greatest service for the latest and greatest browsers. It's not a choice. You can do both. Now, there's a bit of a myth, I think, with this approach, is that people think, wait, if I'm thinking about how stuff behaves in older browsers, that means I'm going to be spending all my time in older browsers. And it's the complete opposite. Because I know exactly how older browsers are going to behave. They're going to get the basic but boring functionality, but they can accomplish their tasks. So I don't need to spend time in older browsers. By taking this approach, I spend so much more time with the latest and greatest browsers, trying out the latest APIs that are only supported in one browser, and I can do that safely, right? It's like I've created this safety net. In development terms, we often talk about technical debt. Some decision that was made in the past, and now it's biting us on the ass years later, and we're paying for it. Well, the way I think about this approach is that you're creating technical credit. By spending that time with step 1 and 2, you've got carte blanche to kind of go crazy at step 3 and do what you want. It's a way to be responsible about using the latest and greatest APIs, even if they aren't supported in many browsers. But I get pushback on this. I get people saying, this is too easy. Or rather, this is too simplistic. It's naive. People might say, yeah, well, this would be fine for a simple website like a blog, but there's no way it could scale to the really complex, big organizational thing that I'm working on. And what's funny is I've heard this before. I remember when we were switching from tables for layout to using CSS, and people would say, well, using CSS for layout, that's fine for a little blog, but there's no way it could scale for this complicated corporate website I'm building. And then Doug Bowman did the Wired.com redesign, and we got ESPN.com, and then the floodgates opened. And a few years later, responsive design comes along, and people reacted by saying, well, Ethan, that's all well and good for a simple little blog or portfolio site, but there's no way it could scale for this complex organizational app that I'm building. Then the Boston Globe launched, and all these other sites launched responsive redesigns, and the floodgates opened. And there's an opportunity here to open the floodgates on really powerful web apps that make full advantage of the latest APIs, and yet still work in older browsers, proxy browsers like Opera Mini, millions of users, but not many features. I'm saying you can support both. There's a huge opportunity here. You know, the other pushback I get, apart from people saying, nah, this is too easy, this is too simplistic, the other pushback I get is people saying, that's too hard. Like looking at that 3-step process, let's say I do that. You're saying I spent all this time making it work the old, boring way, the client-server model, and then I come along and enhance and do the Ajax and the cool JavaScript stuff. Aren't I going to have to create everything from scratch again? Aren't I doubling my workload? And I won't lie, it is going to take more time at first. But then it'll get easier. And again, we've been here before. If you were making websites with tables for layout and then you moved to CSS, I guarantee you that first time you tried making a CSS layout, it was really hard. Second time was a bit easier. Third time was easier again, and then it just became normal. And if you were used to building fixed width websites and then you tried to make a responsive site, it's a world of pain, right? You're not used to it. The first time you try and do it, it's really hard. Second time, it's still hard, but it's a bit easier. And then the third time, it gets easier again, and now it's just normal. And it doesn't take longer. Well, it's the same with this 3-step approach. It is going to be harder to think in this way. The first time you try and build this way, it will be tricky. And you might be thinking, well, I've got this really complex thing, it couldn't possibly work. Those use cases do exist, but I think they're few and far between. Maybe if you're building an in-browser game, right, that requires WebGL, well, there, I mean, you're applying this process, the simplest possible technology would be WebGL. So that's your baseline. But that's a pretty extreme case. Most things on the web are transactions and information, and they can be enabled with these boring technologies and then enhanced with the imperative layer. Although if you were going to make a game like that, I would love to see a game where it starts as a text-only adventure game in the older browsers, but turns into like a first-person shooter in newer browsers. That would be pretty sweet. But yeah, you know, there may be some duplicated work, making it work the boring way and then enhancing. These days, though, you know, there is the possibility of JavaScript on the server and JavaScript on the client, universal JavaScript, I think we're calling it now. We're not calling it isomorphic anymore. So there are options. So doing it this way, it's kind of an irony here. By making sure you've got this backwards compatibility built in, you're giving yourself carte blanche to use the latest and greatest APIs and make it really all singing, all dancing, and ready for the future, right? You get to be future friendly. And there's a bit of an irony here that the best way to be future friendly is to be backwards compatible. But I don't see people building this way. And I've been thinking about why this might be. And the unfortunate truth may be that we, as a community, tend to value developer convenience above all. Now, don't get me wrong. I'm a developer. I want convenience. I do not want my life to be hard. I value developer convenience. But there's got to be priorities here. And I don't want to value developer convenience above user needs. And I don't mean some users' needs, I mean all users' needs. Now, most of the time, there isn't a conflict here. We get developer convenience and we provide for our users' needs. But in case of conflict, I will always value user needs above developer convenience. I've said it before, if I'm confronted with a problem building for the web, and I have the choice of making it my problem or making it the user's problem, I'll make it my problem every time. Because that's my job. I'm getting paid to do this. This is why it's called work. And yet, we tend to just complain about our lives as developers, even though it's not about us. It's about them. And the web's littered with this litany of complaints about how we haven't got what we need yet, right? Oh, the web is going to be so much better when we have more than 216 colors. It's a true fact. One time we only had 216 colors that we could play with on the web. And we complained about it, and then we were like, oh, the web is going to get so much better when we can have more fonts than just the system fonts that come installed on the computer. And the web is going to be so much better when people upgrade from Netscape 4. The web is going to get so much better when people finally upgrade from Internet Explorer 6. If people that are on Windows XP would just upgrade, then everything would be fine. If those Android version 2 users would just upgrade, there's always something. Right? There's always something. We're never happy. My friend Frank wrote a wonderful essay many years ago called "There's a Horse in the Apple Store." And in it, he describes his experience of walking into the Apple Store and seeing a tiny pony in the Apple Store. And he describes seeing a tiny pony in the Apple Store. But he also describes the reaction, or complete lack thereof, by all the people in the Apple Store, distracted by the new shiny. And he's taken to calling these things that are right in front of our face, that we don't realize are amazing, these miracles. He calls these tiny ponies. And I put it to you that the World Wide Web is a tiny pony. It's this amazing thing, and yet we're complaining about what it can't do. We're always comparing the web to something else. In the 90s, it was CD-ROMs, and then it was Flash, and now it's native apps, and we're always seeing what other things can do that we can't do, and yet we fail to realize what only the web can do. And it's been there from the start. That's URLs. The most amazing software distribution method ever invented. You just go to a URL, follow a link, type it in. You can write it on a Post-it note or stick it on a poster. And also, that it's not just about instantaneous solving a problem right now, access to information right now, fulfilling a task right now. With URLs, you can make things last over time. That's a big difference between the web and everything else. Using URLs and treating them right. Cool URLs don't change, right? Then we can extend the reach of our networks for future generations. We can extend the reach of the collective knowledge of our entire species. That's quite a heavy responsibility. So we need to be good ancestors. We need to leave behind a web that lasts. We need to leave behind a web that's resilient. Grazie.